cardiac output measurement. So cardiac output is the amount of blood delivered by the heart to the aorta per minute. So for normal adult, the cardiac output is 4 to 6 liters per minute. So cardiac output is nothing but the amount of blood delivered by the heart to the aorta per minute. So here why we study the cardiac output means it is necessary to study the various cardiac disorders. So to decrease in cardiac output is due to low blood pressure, reduced tissue oxygenation, poor renal function, shock and acidosis. So these are the affect the cardiac output. So this low blood pressure, reduced tissue oxygenation, poor renal function also affect the cardiac output measurement. So based on this cardiac output, it can be measured by using three methods. What are the method means? Fixed method, indicator dilution method, measurement of cardiac output by impedance change method. So using these three methods, we can calculate the cardiac output measurement. So cardiac output is nothing but amount of blood delivered by the heart to aorta per minute. So here three types of measurement can be used to measure the cardiac output. That method is fixed method, indicator dilution method, measurement of cardiac output by impedance change. Next, indicator dilution method. This method can be used to measure the cardiac output. So in this method, a known amount of dye or radioisotope is used as an indicator in the blood circulation. So indicator dilution method, here the indicator is dye or radioisotope. So this dye or radioisotope can be used as an indicator in the blood circulation. So and then measuring the concentration of the indicator with respect to time. So this based on this we can calculate the volume of flow of blood. So in the volume of how much amount of blood it's circulated in our body, we can using this indicator dilution method we can calculate the volume of flow of the blood. Okay, so indicator dilution method, in this dye or radioisotope is used as an indicator in the blood circulation. So based on this measuring the indicator with respect to time, we can estimate the volume flow of the blood in the body. So let an increment of volume dV passes the sampling site in time dt. So we calculate the indicator in dV equal to d capital M. So therefore the concentration of the indicator C is equal to dm divided by dV. So the differentiation of M divided by differentiation of V. So dV is the volume, mass of M is the mass of the indicator. So the concentration of the indicator C is equal to differentiation of mass with respect to volume V. So indicator dilution method, this method is one of the cardiac output measurement methods. So in this method the indicator is the dye or radioisotope. So the radioisotope is used as an indicator is an blood circulation. So the measuring the concentration of the indicator with respect to time. So we can estimate the volume flow of the blood. So let dV is the increment of volume is past the sampling site in time t. So with respect to t we can differentiate we get indicator concentration of indicator C. So concentration of indicator C is equal to T capital M divided by dV. So M is the mass of indicator, V is the volume of indicator. So this is the indicator dilution method. So dm divided by dt is equal to C into dV by dt. So but dV by dt is the Q, that is the cardiac output. So instead we can put dm divided by dt is equal to Q into C. So dV by dt instead we can put the Q. Q is nothing but cardiac output. This is the cardiac output measurement based on the indicator dilution method. Next, integrating over the time, we will get capital M is equal to the time interval 0 to t q into CTT. So q is nothing but cardiac output, C is the concentration of indicator. So we know q is equal to capital M divided by integral 0 to t C into dt. So Q is the cardiac output. Therefore, Q is equal to M divided by area of the curve. So, area of the curve nothing but C into dt. So, this is the cardiac output based on the indicated dilution method. This is the final output, cardiac output measurement. Next, fixed method. So, fixed method is the another cardiac output measurement method. So, in this method, cardiac output is determined by the analysis of gas keeping of the organism. So, this fixed method, how we can determine the cardiac output means by the analysis of gas keeping of the organism. So here the cardiac output can be calculated by continuously infusing the oxygen into blood or removing it from the blood. So cardiac output can be calculated by continuously infusing oxygen. So infusing the oxygen into the blood or removing it from the blood, and the measuring amount of oxygen in the blood before and after its passage. So I is equal to CAQ minus CVQ. This is the formula for calculate the amount of, that is, removed oxygen per unit time. So I is the removed oxygen per unit time. So we need Q is the cardiac output measurement. So we need cardiac output. Q is equal to 1I divided by CA minus CV. This is the formula for cardiac output measurement by using the fixed method. So, how we can calculate the cardiac output measurement by fixed method means by the analysis of gas keeping of the organism. So, this is the formula I is equal to CAQ minus CVQ. Here the Q is the common value, so we get out from this means we get I is equal to CA minus CV into Q. So, we only need Q, that is cardiac output. So, cardiac output Q is equal to I divided by CA minus CV. This is the necessary cardiac output measurement formula. Next one, this is the heart lung, that is pulmonary function of heart. So, this is the fixed method. Here the heart center part is the heart and lungs. So, here mixed venous blood is enter into the vena cave and the oxygen enter into the heart, and artery is remove the blood outside from the heart. So this is the general heart and lungs, that is the pulmonary function. So oxygen enter into the heart here, and then heart catheter is mixed venous blood enter into the heart, and the removing arterial blood is the removing from the aorta valve. So this is the general pulmonary function of heart and lungs. Next one, thermodilution method. So thermodilution method is the another cardiac output measurement. Here in this block consists of amplifier, indicator circuit, microcontroller, output display unit and control unit. So here thermistor for blood temperature, thermistor for temperature for thermal indicator. So this will be connected to the amplifier, and output of amplifier is connected to the indicator circuit, and then the microcontroller can be used to control the overall blocks. So here the thermistor for blood temperature. Here another amplifier consists of input, a thermistor for temperature for thermal indicator. So we know that function of amplifier, it can be used to boost up the biological signal strength. So this output of first amplifier is connected to the indicator circuit, and next the output of amplifier circuit also connected to the microcontroller. So the microcontroller can be used to control the overall function of this circuit. So for this microcontroller output can be connected to the output of display unit. So this displays video recorder and display the system to produce the output, cardiac output measurement. Here the indicator circuit also consists of timer or control unit. So this is the output of microcontroller. The timer or control unit is the output of microcontroller. So we get the output dm divided by dt is equal to C into dV by dt. So this is the thermodilution method. So thermodilution method also a cardiac output measurement method. It consists of amplifier, integrated circuit, microcontroller, timer controller and display unit. So here the microcontroller is the central control part of the system. So here this two amplifier in this blocks consist of thermistor for blood temperature and a thermal indicator. So the first amplifier output is connected to the indicator circuit, that is integrated circuit. Integrated circuit can be used to integrate the amplified signal, and also it is comes from the control unit. The output of microcontroller is the control unit, and then this microcontroller produces the output to the display and the output display unit, that is the video recorder or messages produced on the output of the display unit. In this display unit we can see the cardiac output measurement. This is the thermodilution method by use cardiac output measurement. Next, measurement of cardiac output by using the impedance change. So by using the impedance change we can calculate the cardiac output based on the electronical method. So here the 4 electrodes are placed surrounding the thorax. So the electrode pair 1 and 4 used as the current electrode, and electrode pair 2 and 3 used to pick up the voltage across the thorax. So the cardiac output can be determined electronically by the impedance method. The 4 electrodes are placed surrounding the thorax. So it consists of 4 electrodes. One electrode pairs 1 and 4 used as the current electrode, and electrode pair 2 and 3 used to pick up the voltage across the thorax. So the resistance of the thorax is given by R is equal to rho L capital L divided by A. So the capital R is equal to rho capital L square divided by A into L. So here the L is a cancel, and then we get rho V is equal to rho L square divided by R. So instead we can put capital V. So rho L square divided by V. V is the volume of the thorax. This is the calculation of volume of the thorax. So differentiating the expression for V. So we get dV is equal to minus rho capital L square divided by R square into dr. So differentiation we get dV is equal to minus rho L square divided by R square into dr. So here excitation is used, so impedance Z is used instead of R. So therefore we get dV is equal to minus rho L square divided by Z square dz. So since AC excitation is used, so the impedance Z is used instead of capital R. So therefore dV is equal to minus rho L square Z square into dz. So this is the block diagram of impedance change method by using cardiac output. So here the 4 electrodes 1, 2, 3, 4. So 1 and 4 pair electrodes can be used to current electrode. 1 and 4, 2 and 3 is just a determinant in between the thorax, determination of volume between the thorax. So here 2 and 3 is a potential electrode, and 1 and 4 is the current electrode. Here this amplifier and demodulator can be collect the signal from the human body and then amplify this biological signal and demodulator and produce the output Z, and it will be connected to the differentiator block. So the differentiator can be used to difference the signal and produce the output unit, that is differentiation unit. This is the impedance change method can be used to calculate the cardiac output. This is the the cardiac output measurement by using the three method, that is fixed method, indicator dilution method and impedance change method. So cardiac measurement is nothing but amount of blood delivered to the heart to aorta per minute. This is called cardiac output measurement. So this cardiac output can be calculated by using the fixed method, indicator dilution method and impedance method. This is the necessary explanation of cardiac output measurement.